Chapter 22, Electric Field. We cover three topics. Number one, source charges produce electric field. Number two, electric field, three examples, created by a point source charge, created between parallel plates, and also the simple case of the electric field far away from a dipole. Electric force on the probe charge is depends on the charge and the electric field. So let's look at the details. One single positive charge can create an electric field. So electric field magnitude is given by K times the charge of the source and divided by R squared. And the direction is going away from the positive charge. Here, the electric field lines are the lines, solid lines with arrow. You can see two things from the field lines. Number one, the density represents the strength. So when the lines are closer together, that means a higher magnitude. And also the direction pointed by the arrows. Negative charge is similar, except the electric field points towards the negative charge. Another type of electric field that's going to be used very often in this class is what we call electric field between parallel plates. These electric fields are uniform, meaning between the two plates that are very close to each other, the electric field is a constant with the same magnitude and direction at every point. So here we talk about the uniform field. So here, one example of electric field created by a point charge. So the source is the electric field. Next topic, we talk about, so after we talk about creating electric field, next we talk about what if you bring a probe charge into electric field. So in the existing electric field, for example, if I bring a positive charge, then the force is along the same direction as the electric field. If I bring in a negative charge, then the field is opposite the direction of the electric field. Snowflakes are very interesting because each one is very unique, and also, of course, no two are identical. All are symmetrical in a beautiful way. Snowflakes are formed by water molecules. Water molecules have a dipole moment. What is a dipole? Okay, so a dipole is made up of two charges, positive and negative, separated by a distance. So water has a certain dipole moment. When two water molecules get close to each other, they're going to attract each other, and gradually they can form snowflakes. Dipoles. A dipole is made up of two charges, one positive and one negative. They're separated by a certain distance. So around the positive charge, there's electric field, and around the negative charge, there's electric field. So together they create electric field around them. In the example of, we have a positive charge and negative charge, each of magnitude a big Q, and they're separated by a distance of D. So in the simplest case of having a point along the dipole axis, here we call Z, the dipole axis is along the line that passes both charges. And when it's far away from the dipole, meaning when Z is a lot larger than D, for example, like more than 10 times larger. So the condition for applying the dipole the electric field caused by dipole is along the z-axis and far away. Let's see, in this case, can we apply that? If you have 2-point charges, if I like to calculate, find out the electric field exactly in the middle of these 2 points, can I apply the dipole equation? The answer is no, because this is, although this is along the dipole axis, but it's not far away from the dipole. So in summary, we introduced that source charges produce electric field. And we look at 3 special examples of electric field by point charge between parallel plates and the z-axis far away from a dipole. Lastly, we introduced the force on the probe charge in the electric field.